Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. Many moons ago I purchased this showerhead and it's still functional as a showerhead, to be honest, but showerheads are pretty cheap, like literally £5. I don't feel too bad about destroying this one in the name of science, and the reason it's going to be destroyed is that it has some LEDs in here and it's supposed to have had a water turbine. So when you put water down it, the pressure of the water is supposed to spin something and it would change colour from blue to blue, green and red to tell you if the water temperature was correct. And the colours were really weird, like it's not colours we'd want in the West necessarily. It was peculiar, I remember that much. But it never really worked properly and then it stopped working because frankly we don't have enough water pressure, I suspect. So I've always wanted to get into it, and I've always noticed inside you can actually see screws, but of course they're all underneath this domed component, which we have to get off first. Now, you saw me gingerly rubbing it with a Stanley knife or a box cutter, if you're from the US of A, to see if that will loosen it. Clearly not. And it's hard to really work out how far this plastic goes into it, because it could be a really thick piece of plastic and it could, and probably does, have glue on it. So I'm going to work at this for a little while and let's see if we can get in. Yep, it's not looking like this is going to be a realistic solution. So I think we need to get a better tool. Oh, I do have some tools lying around next to me, fortunately. So I think we're going to try the old vicey grippies. Now, I could just smash the back with this. That's an option. But before I do that, just before I do that, let's see if we can just give it a little bit of a crunch. See if we can crunch this up a bit. Let's get that out of the way before we do ourselves a mischief. Oh yes, it definitely crunches. Look at that. That's got a nice old bend in that. This is quite a soft plastic. I suppose if I do that, I run the risk of damaging our precious LEDs. So I think we're just going to give it a sharp thwack. Cover your ears. Now I tell you what, I'm super impressed with this. I might not be impressed with it as a illuminating showerhead, but boy oh boy, can it take a beating. That's phenomenal. Have a look. This succumbed to the power of my bench sander. Look at that. Tore around the edge. Ended up with this inner part. Now, this is the part that's interesting to us. So you can see there the water comes in and eventually works its way out through these apertures here and then through the holes in the front panel. There's no adjustment on it. No little plastic dingly danglies that we like. Looks like we have a temperature sensor here and a soft silicone-y potted silicone. Now we can undo those screws, which we're going to do now. It's interesting it is screwed though, isn't it? For something that's totally bonded construction, why didn't they just bond this pie? Hopefully my sanding is giving us enough access to get this thing out without catching. Well, it is catching. Of course it's catching. Now, fun fact, I ordered a replacement shower head and shower hose from Amazon for this particular shower. But the weird thing is, the new shower head actually came with a shower hose. So I ended up with too many hoses. Too many hoses is my problem. Let's get rid of this little bit here. But the fun fact is, the shower hose is a copy of a, I want to say Grow, I don't know how to pronounce it. Answers down below. Flexible shower hose, which I really like. They're not like the one which is the old chain wrapped around a rubber hose. They're the ones which look a little bit like a silver garden hose. If you haven't got one of those, get them. They're so good. They're so much better. And if you get the actual proper ones, they have a really good slip kind of bearing on it, which lets the shower hose rotate around so it never twists itself up and punches itself. Right, that should be enough now. Get an awful lot of crud, and I'm trying not to damage it too much because, oh, I can see there is a turbine there. Woohoo! Right, let me bin this part. Are you really interested in keeping this? Probably not. We're done with that. We're never going to look at that again. Oh, or will we? It was kind of cute to see how the water would have gone past. But anyway, look at that. You can do it. I reckon that would have been really hard to turn though, wouldn't it? Let's get the other bit. I jumped the gun, I'm afraid. I did jump the gun because we did need to see how this water works. And you can see there, it's like a turbo. That will have been there, that turbine. So the water will have run around it and then escaped out of here. And then obviously cause that to illuminate on its way. And any water that gets to the front here will have hit that temperature sensor and given us a different light. But I wonder how it works, because you can see here, of course, you can see the green flashing. I wonder if there are different sets of LEDs in here. Realistically though, to test this, we're going to want a way of spinning it. Now I could get the air compressor and hook an air compressor up and try to blow against that, which is a bit of a faff, but oh my word, it's even better. Look, it's completely sealed. Oh my gosh, I think we will have to use an air compressor because there's no shaft to bond to, so there's a little bit of grease on there, and I'm introducing an awful lot of grit into this system. But look at that, it's totally inductive, so that's a magnetic, well, it's a magnet there, and it's like a tape. I'm guessing it's got north-south, north-south, north-south on it. It wouldn't be one pole. And as that's spinning around here, there's a coil behind there which is getting induced, a charge, which we're seeing there ultimately. And you can see a nice bearing in that. That'll be brass or something similar. It would be interesting to figure out how do we spin this so we can test it at full whack. So I took a coach bolt which I ground, and you can see it was hot because you can see my finger here. There's a big burn in it when I touched it. And while it was hot, I decided to press it into the back of this, hopefully not going so far as to damage the bearing, and hopefully center enough that it will turn. Yeah, it's not quite perfectly centered, but it's probably enough for our purposes. So let's zoom out a little bit, give me enough room. Look at that, it really smells. I could smell myself burning. Woohoo! So you saw that. So there are different LEDs. And it seems to go through a colour cycle pattern when it warms up. Now, sorry, when it powers up to probably let you know that it's up to speed. Now how, we got to apply heat somehow. We need a lot of hands here, but I do have a bench solder reflow heater. This is going to be tricky. Let me figure this out. It's a little bit jury-rigged, but you can probably just about see. Hopefully the camera can focus on this. I've got a little cord that's attached to the bench to stop it from going too far, which I'm going to try to keep tension on like that. And I'm going to turn on now the hot air, and we'll heat this up as the whole thing's running. There'll be a lot of noise basically, but let's see if we can get it to change colour. And you can see the different temperatures. I think green is the starting, so I think it goes from green, blue, red, which conversely is probably not the way I thought it worked, but it doesn't matter. Heat. Ah! No. Hang on. Well, there we go. We certainly got that working there, so you saw that. It was interesting because it lingered on blue. Let's see if it continues to linger on blue. I wonder if it's got some residual heat in it, because... spray a bit of water on it, shall we? Because it did start up on green, like green's super cold. Let's see. Yeah. So that's my problem with it. It starts with green, and then it goes from blue and then red when it's hot. So the ideal temperature on this would be marked as blue, but I don't understand. Surely blue would be too cold, red would be too hot, and green would have been just right. Look at that though, we've invented a really inefficient torch. Yeah! Brilliant. There we go. Hope that's been of some interest to you guys. Please like, share, subscribe, and as ever, thank you for watching. I'm going to have so much fun with this. I was literally just editing the video and I thought to myself, hang on, what are we saving this for? Ultimately, beyond this, what are we going to do with it? Probably not much. Let me show you, by the way, my beautiful coach bolt. Look at that finish. All done without a lathe too. Mwah. Anyway, enough coat bolt admiration. Let's see if we can get into this a little bit, because we did see that it was potted with some sort of silicone. Maybe let's just pick it out. We can just get some out. I'm just curious to see what's in here. Probably some sort of blob of a chip on board, but maybe there could be something else. In fact, we're really lucky because it's one of those quite crunchy varieties. Yep, I do see a blob. There's something there for sure. Might try to be a little bit less aggressive with this. Seem to be some markings. LED 10 right there in the middle. So there's potentially other LEDs on this. Maybe it was used for different designs. Now that bit there is curious. It does seem to be a blob. But is that really where we'd expect one? It's a capacitor. It's a capacitor in the board. So it's a capacitor in the PCB itself. Let's keep going. We want to get to the point where we can lift that PCB, don't we? So we have to keep going there. Now let's try not to damage that thermistor. Making an awful mess, but it's okay. Now if we can do it without damaging the LEDs, oh, the board's coming out perfect. That's what we wanted. That's fine. You can come out. Come out to play. Warriors! Come out to play! Beautiful! Look at this! I'm so glad we did this. I'm so glad you convinced me that I needed to make a video with slightly more in-depth content than just playing with something. Look at that! We have an IC there, which I feel I might be able to read the markings on. Hang on. Let's give it a little... Oh, I don't know, you know. It's one of those ones which looks like it might have markings, but probably doesn't really. I think it's a PIC 12 variety, right? So there's our coil, and is it broken? No, it still works, so we can spin that. It's like a little generator. Just put it up against the wind. So let's see what we have here. So we have a whole bunch of diodes. D6, D5, D4, D3, D2, D1, so and 3 of these. I don't know what that is. Is that acting as a rectifier? I think it probably is, you know. Shame we can't have this running permanently and we could probe this, but I think it's being rectified through these small signal diodes. And then you have a Q3, which, let's see, going there. Just trying to trace around some of these. Be interesting to see if there's a common. I think there's a common around here. I think you have 3 transistors, basically. You have 1, 2, and 3, and they're going to be the 3 different channels. And you have a 0 ohm resistor here at the top, so it's just, that's why it's single-sided PCB, but they obviously needed to make a jumper across there at some point. What else can we see here? When we have a microcontroller, that thermistor is connected here, so that here and here, those are the 2 thermistor points. So I suspect all that's happening is you've got a thermistor coming in, and this microcontroller is doing the business, and it's pulse width modulating these appropriately, and they will be flashing. And I don't think they're just flashing see, it's hard to show it now. But when this was running, I think you noticed there was a slight flicker to them. They weren't entirely steady, and I suspect that's a energy saving mechanism. It's probably always to it really, and the capacitor's just smoothing that out, giving it a little bit of a buffer. So you've got like a few 100 milliseconds of power there. You could see that when you stop spinning, how the light just stays on for a bit longer. I know there's some inertia from the wheel too, but you could see it's only at peak spin you're actually getting something going. There you go, that's your little extra bit there. So hopefully that was a bit more interesting. Gosh, just fascinating, isn't it? It's just so cool how that little coil there is been wound. So when you see these on eBay for a £5, you think, yeah, there's a fair bit goes into them really. You wouldn't be able to make this for a £5 and make the whole shower head as well.